So the third type of concentration that we're going to look at, the way we calculate it, is by far the one most used most commonly in by scientists and lab technicians and stuff like that in a more scientific context, and it requires a bit of a knowledge about the basic chemistry of the solution that you're dealing with. Okay, and so the symbol is C. That one's correct. That's how it's in your data booklet as well. Okay, the units though are moles per liter. So the equation is C equals N, again, an amount of solute in moles over a volume in this case. So the amount of solution is the volume, okay, in liters here. So what is a mole again? You'll have to think back to Science 10. Basically, 1 mole is the amount of a substance you have when you have this many atoms, 6.02 times 10 to the 23 atoms. So basically a 6 and then 23 zeros. That's a huge number. It's a lot of atoms or molecules, okay? Where does that number come from? Well, essentially, it's named after Avogadro. He started counting, he didn't literally count atoms, but you can think of it like that. He said, how many atoms or molecules would you need until the atomic mass, okay, of the element, remember atomic mass on the periodic table is the one below the name. So like for hydrogen, if you're looking at your periodic table, it's 1.01, right? For lithium right below that is 6.94. He said, okay, how many atoms would you need to equal that in grams, right? Because remember, that's the number, the atomic mass on the periodic table is the number of protons or neutrons. The Avogadro's number is how many atoms you would need to not just have that number be equal in grams. So for example, if you had an Avogadro's number of hydrogen atoms, you would have 1.01 grams of hydrogen. If you had an Avogadro's number of lithium atoms, you would have 6.94 grams of lithium, right? So essentially a mole is the number of atoms or molecules it would take to have its mass in grams be the same as its atomic mass, which is just number of protons and neutrons, okay? All that is to say is just to remind you what N means, so it's not some weird number that we throw at you. It's back from Science 10, essentially, okay? So an example, a beaker with a 0.5 mole, a beaker containing 0.5 moles of hydrochloric acid in 2 liters of solution will have a hydrochloric acid concentration of 0.25 moles per liter. How'd they get that number? Well, C equals N over V, right? So they took the N, divided it by the V in liters, 0.5 divided by 2 is 0.25. Okay, and so the third and final type of concentration that we're going to learn about, it's not the last equation, but it is the last type of concentration, is actually the most popular within at least the lab, the science lab, okay? That is molar concentration, okay? And as the name implies, molar, okay, it has to do with moles. So remember, all concentrations are a way of comparing the amount of solute to the total amount of solution. So when we're doing molar concentration, actually, let's go back. When we were doing percent by volume concentration, right, percent by volume, we were comparing the volumes. When we were doing the ppm, we were comparing the mass of solute. In this one, we're going to compare the number of moles of solute to the total volume of solution. So we would say this is our main equation, our best friend here. C equals N over V. N of the solute, N being moles, V being solution. I know it seems a little bit weird at first that N is moles, okay, but you got to remember M as in monkey, was already taken by mass, right? So they couldn't use M. How I think of it, and often how you'll actually see it written, and this is a little trick to help you remember, don't think of it as N for moles, think of it as N for number of moles, okay? And really that is how it's written a lot of the time, okay? So this would be the number of moles. Okay, now this is a little bit different than our other ones when it comes to units. So if we are going to use C equals N over V, remember with percent by volume, it was okay. We could use milliliters, we could use liters, as long as we use the same thing for our solute and for our solution. Same went for ppm. We could use grams, we could use milligrams, whatever we wanted, as long as we use the same one for each, okay? That is not the case here, okay? So for our units here, they're a little, this equation is a little more picky with its units, let's say, okay? So for units, you don't have an option. N must be in moles. MOL is the symbol for moles. Okay. C, actually, let's do V, sorry. V, the volume, must be in liters. You don't have the option. V's got to be in liters. Okay. So the volume, the amount it takes up, must be in liters. Finally, the concentration. If N must be in moles, V must be liters, and C is N over V, then C, it's no surprise, must be in moles per liter, right? Moles per liter. Okay, now the reason there's another equation written here is that often these will be, or not often, but yeah, somewhat often, these will be two-step questions, okay? So what I mean by that is you won't be given moles, but you will be given enough information to find the number of moles with our oldest friend in chemistry that looks a little bit different here because it's all written out, but maybe you'll recognize it if I write it the way you would have seen it in Science 10. Ta-da! You remember that guy? N equals M over M, okay? So the reason this one is written here is because often the question won't be nice enough to just tell us N, but it will tell us little m, mass. You can always figure out molar mass. Okay, I'll remind you how in a second here, but you can always figure out the molar mass as long as you have your periodic table and you know what chemical it is you're looking for. Okay, so I'll just kind of remind you of a trick I use anyway, because it can be difficult to remember which one's which. Little m is just for mass, right? So little m, if you go back here, little m is just for mass. So 1m mass just gets a little m. Big M is for molar mass. Molar mass means, again, the mass of 1 mole. But since big M is for molar mass, that's two M's, right? MM, molar mass. So they put them together into one big capital M. That's how I remember it. Okay, so little m for just mass, big M for molar mass. Again, these tricks are great. They help you maybe do stuff quicker, but you do not have to memorize any of this. It's all on page 10 of your data booklet, okay? Not only the equations, but also all the units, all the symbols, what they mean, okay? That's all there. Okay, so let's get back into it. The molar mass, M. The mass of 1 mole is big M, and the little m is mass. Let's not worry too much about this for now. Let's just jump into an example. I think that's often the best way to see it, okay? But just to remind us, I know I just said we're going to jump in and I changed my mind right away. I just want to say, so C equals N over V, okay? Why do we have these two equations? Because often what we need to do is we don't have N directly, and we need it here, right? We need it here, but we aren't just given it, okay? However, we can get it with this equation and then bring it here, right? So like how would a question look? They might give you the mass. They might tell you what the chemical is, which means you can find the molar mass, and then you can that means you can find the moles, and then you go over here. So this is usually, not always, but usually step 1, and then this is usually, but not always, but usually step 2. Those steps can actually be flipped too. They might give you C and V, so you can get N, and then go over here and get little m, but usually not. Usually it's this way. This is step 1, this is step 2, okay? If it's a 2-step question. So just be on the lookout for 2-step questions. Okay, let's get into it. A sample of water taken from a nearby lake is found to have 0.0035 moles of salt. So this is like our solution, we're making it easier, a salt water solution in a 100 milliliter solution. Okay, so this is, in this case, it's found to have 0.0035 moles of salt. So right away, moles, okay, that's an N, right? N in a 100 milliliter solution. So milliliter is a unit of volume, and you don't have to memorize that, right? You might memorize it by the end of this, but liters and milliliters are given as the unit of volume on page 10 of your booklet. So that is V, okay? The concentration of salt in the lake expressed in scientific notation. So it's just another one of these. So what are we looking for? C is blank, 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 okay? So we're looking for C. So remember, we have to be careful with units here. N equals 0.0035 moles. Okay, that's okay, right? That was fine. In fact, N has to be in moles. I'm just going back up to the top here. N must be in moles. My V, though, is equal to 100 milliliters. Uh-oh, V must be in liters. Okay, that's all right. We can convert milliliters to liters. So remember, milli means 1,000th, right? So that's one clue. There's also on page 1 of your data booklet, okay, so page 1 of your data booklet, there is some, all these conversion factors are there. So M, little m means milli, and that's 1/1000th or 0.001. However, if we do our conversion, right, let's just do it right away so we don't forget. I can say I want milliliters to cancel out and be replaced with liters, right? And now what I'm trying to say is I need to multiply by this number that's not going to change the value, it's just going to change how it's being measured, right? So in other words, this needs to be, I always call it a fancy 1, right? Because the only number you can multiply something by and not change it is 1. How do I make this really be 1? I have to make the number on top be the same thing as the number on bottom, just kind of said a different way. So how about if I said, well, 1 liter is the same thing as 1,000 milliliters. What am I saying? I'm saying 100 milliliters times every liter has 1,000 milliliters, right? So if I've got 100 milliliters, then how many liters do I have? Well, I'm going to have 100 divided by 1,000 in the end, right? Milliliters are canceled out, leaving me with liters. And so the volume is 0.1 liters, okay? And concentration is what we're looking for. So just be careful on these. Make sure your volume is in liters. Okay, let's jump right in. We need, like always, an equation that has a C, a V, an N, and a nothing else. So if you go to page 10 in your data booklet, look at that. By the way, guys, sorry, I don't know if I mentioned it. We are on page 12 of your notes. Okay, if you're following along your notes, we are on page 12 in that purple note booklet. Okay. All right, so you need a C, an N, and a V. So C equals N over V. And our lucky day, what we want, C is already all by itself. I don't need to do any manipulating. And so C equals 0.0035 moles divided by 0.1 liters. And we'll get that the concentration is 0.035. What are my units? I've got moles over liters. So of course, moles per liter. So in every liter, there's 0.035 moles of my solute, which in this case was salt. Okay, GRAS, done. Paraphrase, have I answered it the way I wanted it to? No, I have not, because it wanted it at like this, A point B times 10 to the negative C. So that means I need to write this in scientific notation. Decimal is here now. Where's it got to go? Okay, it's got to go between the 3 and the 5. After the first number, that's not a 0 when you read it left to right. So 1, 2. Okay, there we go. Cool. That means the decimal's now there. 3 point to 2 sig digs, or to A point B, 3.5. There's my A point B times 10 to the power of, how many times did I move the decimal? I moved it twice. So 3.5 times 10 to the 2, but don't forget this is a small number, right? We're actually going to be dealing with quite a few small numbers in our chemistry unit. So it's not times 10 to the 2, it's times 10 to the negative 2, right? When you multiply by 10 to the positive 2, you're multiplying by 10 and then multiplying by 10, which is multiplying by 100, right? When you're multiplying by 10 to the negative 2, you're multiplying by 1 over 10, 1 over 10. Or in other words, dividing by 10 twice, okay? That's how you get a small number, divide. If you multiply, you're going to get a big number. Anyway, times 10 to the negative 2. Okay, moles per liter. So when we write it like that, what are A, B, and C? Well, A point B times 10 to the negative C. So they put the negative in there for us, so you don't need to do it, right? They said times 10 to the negative C. On a Scantron, as you probably know, there is no negative, so we're good. We would just say that the answer is A, B, C, 3, 5, 2. Okay, or in the box, 3, 5, 2. Okay, now this is an example of one that it is, I guess, a two-step question. They were nice enough here to split it up into the 2 steps for us so we really can see that, okay, first we'll do A, then we'll do B. Just be aware that sometimes it might just put them both together. It might just jump straight to B, and you kind of need to know to do A. But in this example, they've really kind of given it to us, right? That first do this, then do that. So you dissolve 30 grams of sodium sulfate into 300 milliliters of water. Now I dissolve 30 grams, okay? So what do you dissolve, right? Do you dissolve the solute or do you dissolve the solution? You dissolve the solute to make a solution, right? So this is M solute. That thing is getting dissolved into 300 milliliters of water. So that's a V, that's V solution, right? The number of moles of sodium sulfate in this solution expressed to two significant digits is blank, 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 blank moles. Okay, so yes, they gave us V solution, right? What it's asking for, the number of moles, that is N, okay? So yes, they gave us V, but is that going to be useful here? Well, let's see. N is what we want. M, they gave us, right? M solute, I should say. They gave us is 30 grams. Great. Okay, cool. They gave us V. We might as well write it down. V equals 300 milliliters, right? Down here, they're going to want C. They actually don't want C here, right? Now you're looking at this, and if you go to your data booklet, like you always should, you'll notice there's nothing that has NMV and nothing else, right? There is nothing there that has those three things and nothing else. No equation, okay? Which means I'm going to have to find N with something that maybe we kind of forgotten about since Science 10, and that is the molar mass, okay? So how I usually say it is M. Do we know it? I mean, I guess not, but we always, always, always can figure it out, okay? As long as you got your periodic table, you can find the molar mass, okay? As long as you, so I should say, as long as you have your periodic table and you know what it is, what the chemical is, and we do, right? We can find the molar mass of our solute because they told us it's Na2SO4. So a bit of a recap on how to find the molar mass. It's pretty straightforward. It's always the same process, okay? You add up the atomic mass of each element that's involved for every time it appears. Okay, so what I mean by that is, say for example, H2O, water, right? I'll just write that quick. Say for example, H2O, we would add up the atomic mass of two hydrogens, so that would be 1.01 plus 1.01, and then add on to that the mass of one oxygen. So if you look on the periodic table, oxygen is 16.00. So you would take 1.01 times 2, if you'd like, or 1.01 plus 1.01 plus 16, and that should give you 18.02. So the molar mass of H2O, water, would be 18.02 because we just added everything up. So let's do it. They gave us a big one, but is it any harder? Not really. Maybe a little more work, but it's not harder. It's still just adding, okay? Let's get the molar mass. I'm just going to say find M so I know what I'm doing here because this is, I guess, kind of a two-step in its own, although we can always find this. So for sodium, okay, how many sodiums do we have in sodium sulfate? Well, it's Na2. So we have 2 times the atomic mass of sodium. So Na, if you look on your periodic table, sodium has a molar mass of 22.99. Okay, so I just do them all separately. 2 times 22.99, that gives you 45.98, and the units are grams per mole. That makes sense, molar mass, right? The mass of 1 mole. So how many grams a mass are in 1 mole? Grams per mole, right? Okay, next one, sulfur. So S. Now, how many sulfurs are there in sodium sulfate? Na2SO4. Well, just one S, right? Nothing after, so just one S. So 1 times sulfur, if you look it up, okay, on the periodic table, it has an atomic mass of 32.07 grams per mole. So 1 times 32.07 is 32.07 grams per mole. Okay, great. Now we need to do oxygen. Now, how many oxygens are there? Oh, 4. So in sodium sulfate, there are 4 oxygens, which means its molar mass is going to be contributed 4 times. So we would take 4 times oxygen's molar mass is 16.00, and that is 64.00 grams per mole. So if we look at this, what we have here, right? Each thing, sorry, this 45.98, that's how much the sodium is contributing by being here, okay? This 32.07, that's how much sulfur is contributing by being here. This 64, that's how much those 4 oxygens are contributing by being here in this sodium sulfate. But we want to know what's the total molar mass. So how do we get it? Well, just add up what they all contributed. Okay, so literally just take all 3 of those numbers now and add them up. And I got, when I did it, 142.05 grams per mole. Now, that's not our final answer. Remember, this is M. Okay, this is the molar mass, M. So equals 142.05 grams per mole. Okay, now what can we do? Let's just think about what we got. We've got M, we've got big M, molar mass. Okay, yeah, we got V, but look at this. Do we have an equation that has N, little m, and big M, and nothing else? You betcha, it's your oldest friend in chemistry, right? From Science 10. This guy. Little n equals little m over big M. Big M because it's molar mass. 2 m's, stick them together, you get 1 big M. And it's our lucky day. We don't even have to manipulate that. N is already solved for, and that's what we wanted, right? Don't lose sight of our goal. This is what we were doing. This was just a step along the way, okay? So we got that, we're good. We can get the number of moles. So enough talking about it, let's do it. N equals little m, mass, 30 grams, over the molar mass of this whole thing. So the molar mass of the whole thing is 142.05 grams per mole. That's how many grams there would be in 1 mole. And when you do that, I got, before rounding, 0.21119. That's probably enough. Let's just check our units too. I've got grams over grams, so those cancel, and then that's 1 over moles. So 1 over moles, which is just moles, right? When you do 1 over, they get flipped. So there we go, good. I got moles. I wanted moles because I knew I was finding N. So units, again, a free way to check your work. Take advantage. All that's left to do is check our sig digs. So 2 there. Okay, let's just keep reading. 3 there. So the lowest number of sig digs is 2, and that's what my answer should have. So N equals 0.21 moles. So what would be my answer? That, 0.21. Okay, that's 2 significant digits. Okay, now, like I said, this one has kind of split it up to us. Sometimes you might just have to do that on your own. You might just have to know how to find N. Okay, for example, on your extra practice assignment, I know there's one like that. So N equals 0.21 moles. Now it's saying what's the molar concentration. So with the same givens, and we can even now maybe if we would like, we can call N is no longer a question mark. N, here I'll just say down here, N now equals 0. I'm going to keep some extra sig digs, especially because now I'm going to use this number. I shouldn't use the rounded version, so let's just keep it. We wrote it down, moles. Okay, N equals 0.2119 moles. If you're okay, I'm just going to keep these. These haven't changed, so I'll just keep those same givens. Nothing's changed here. Okay, but now I'm looking for, my required is different. I'm looking for C. Okay, so I've got a C and N. Yes, I've got a mass and a molar mass, right? But those are really, they're not going to help me here. What is going to help me is the V, because we just learned a new equation. So V equals, I know I just said I wasn't going to rewrite them, but oh well. V equals 300 milliliters. Now, careful, what should be happening in your head right now is an alarm should be going off and saying, we're doing molar concentration. We are using C equals N over V, and our volume isn't in liters, right? So we need to say there's no worries, but we just need to multiply by how many liters in a milliliter, right? And there's 1/1000th, right? Or 1 liter per 1,000 milliliters, which means, there we go. I don't know why I did it red, but I did. And that gives you 0.3 liters. Okay, divide by 1,000 because there's 1,000 milliliters in a liter. We've done G, we've done R, we've made sure we convert it into the right units. Analysis, so choose an equation. And yes, lo and behold, we got a C, an N, a V. If you turn to page 10, there's only one equation with all that stuff and nothing else. It's this guy, C equals N over V. Okay, we got N, we got V, We don't even have to manipulate. It's our lucky day. So C equals 0.21119, using the unrounded version again, divided by the volume being 300. No, oh, careful. That was almost a big mistake. 0.3 liters, because it's not milliliters. You got to be in liters. And I got, when I did that, C equals 0.704. What are my units? Moles per liter, right? Because I got moles on top of liter. Okay. GRAS, done, right? I've solved. I've gotten my answer. I just need to make sure it's in the right format. And once again, this is an A, B, C, D question. A point B, C times 10 to the power of D. Just means rewrite it that way and tell me what A, B, C, and D are. So I got to move the decimal from there to there, okay, from where it is now to after the first number that's not a 0 when I read left to right. And so that gives me C equals 7 point A point B, C. So 7.0 is A point B. That means the next number will be my C. Sorry, the next number will be my C, and that's a 4, and nothing comes after it. So 7.04 mole, whoa, what am I doing? Not moles per liter. 7.04 times 10 to the, how many times did I move it? I only moved it once, right? And that's a small number, at least it's smaller than 1. So times 10 to the negative 1. Okay, so C equals 7.04 times 10 to the negative 1, and of course moles per liter. So what our A, B, C, and D are is A, B, C, D. So 7041 would be my answer. Okay, again, I'll put up the whiteboard questions we usually would have had. Okay, and those are, you can pause the video, try those out on loose leaf, whatever. The answers are all there, as well as the mixed concentrations examples practice.